All right, let's get started. Hello, guys. How are you? I hope you are enjoying the conference so far. And even though we are doing it remotely in this way, it's online, it's not the same thing as staying together, but at least we're staying safe. And we still have the chance to learn something. My name is Marco. Thanks for joining me for the next hour. I'm a developer technologies MVP. When I was first awarded 11 years ago, it was on ASP.NET and IIS. Now it has been rebranded in this way, which is very fast as an expertise, as a topic, but I'm still very focused on anything that's related to web and cloud. And today I'm incredibly excited. It's my first time at NDC, and I'm incredibly excited to talk about my two favorite topics. One is security identity management in web applications, and the other one is Blazor, which is probably, hope you agree with me, but it's probably one of the coolest technologies Microsoft is working on at the moment. So yeah, really exciting things to discuss for the next 60 minutes. So what are we going to talk about today? First of all, I'd like to give you a glimpse of the object model that we have available in Blazor to deal with security matters. And then we will see how the security aspects, so the identity management of our users, works slightly differently depending on whether we are in Blazor Server or on Blazor Web Assembly. Works slightly differently under the hood because from the programmatical perspective, what we're going to use are pretty much the same classes, which is cool. Then once we've successfully authenticated our users, we're going to move on and start having including some authorization rules based on roles, and then we will see a way to do a better modeling of authorization than what we can achieve with roles. And then, depending on time, I also have some other goodies to show you, like how to deal with security for progressive web apps or with SignalR. So we will see if we can fit it in this hour, or otherwise feel free to reach me on Slack if you're interested, and I'll be pretty happy to jump on a call perhaps and show you that. Cool. So without further ado, just one last thing. I've tried, since Blazor is still a bit unknown in the landscape, so there's sometimes you talk to people who have very limited experience with it. I tried to keep the talk starting from the basics, but I'm also dealing with some more advanced concepts. So hopefully, regardless to your level of experience, you will be able to take away something out of this talk, or at least I hope so. Cool. So let's start with having a look at the object model. And there are three main classes I want you guys to focus on for the next 5 minutes, right? And because these are the classes that we're going to use throughout pretty much the entire talk, right? So it's very important that we keep them in mind. And the first one is authorized view. Authorized view is a component. We can put it on our pages. And the nice thing about it is that it basically allows me to define a couple of different templates, depending on which we're going to show to the user, depending on whether he's authenticated or not, right? Actually, there are 3 templates here available in the authorized view. The third one is called authorizing, and this is because usually in the context of single-page web applications, the authentication process is an asynchronous operation. So it might be that for a few seconds we might want to display a slightly different template. Okay, in this case, authorized or not authorized means authenticated, because I haven't specified anything, but in this point here I can specify what authorized means, and we will have a look at that later on during the talk. But this is the first class. The other important thing that it gives me is this context object, which is basically an entry point towards the claims principle of the application. So thanks to that, I can access the current principle, I can see the claims identity, I can look at the claims, and all the typical things that we do with claims principles in .NET applications. There's a slightly different implementation of the authorized view called the authorized root view. And this is kind of a mix between the concept of the authorized view and the root view that we use for routing. So what does it mean? It means that if I try to access a URL for which I'm not authorized, I can decide what is the template that I'm going to see, right, as a user. And what does it mean I'm authorized or not authorized? Well, basically, I think that if you guys are like me and have been working with ASP.NET for a while, you know what this authorized attribute means. In this case, again, I'm authenticated or not, or it could be that I specify roles or policies or things like that, right? The important bit that we have to focus on this thing is that this authorized attribute only works in the context of routing. You know that in Blazor you create components, and components can be either displayed as pages when we specify this page directive, or can be embedded in other pages or in other components just by using their markup, right? So in this second case, if we embed them, this thing will not work. So it's a very common mistake, and it's important that we keep it in mind. So the authorized attribute only works in the context of routing when associated to an authorized route view. Right. The third class that we need to get acquainted with is the authentication state provider, right? And this is a class that we were pretty much never going to use directly, okay? But it's the foundation of the two objects that we've seen before. As you can see, it's an abstract class. It's a very simple class. It basically exposes just this method here, get authentication state async, which gives me access to the current principal. And as you can see, it's an abstract class. So this means that it will have, as we will see, very different implementations depending on which flavor of Blazor we're using, whether we are in Blazor Server or Blazor Web Assembly. But the good thing is that the other two components that we've seen so far, they only rely on the abstract implementation. So it means that if we create components, libraries, and things like that, they will work regardless to the type of Blazor that we're using, okay? Thanks to this architectural approach. Right. So let's start by having a look at how authentication works in Blazor. And the idea here is that I'm going to show you some flows in the slides, and then we're going to head to Visual Studio and see it in action. So Blazor Server. In Blazor Server, we know that, and I'll be very quick here because I think that Blazor Web Assembly is the most intriguing part of Blazor, but let's talk about this for the sake of completeness. So in Blazor Server, we have our application which is running on the browser, and the Blazor engine is running on the server, and the two are connected with Azure SignalR. Now, what happens is that if for any reason I have an ASP.NET authentication cookie stored in my browser, SignalR, and this again is a built-in functionality in SignalR, will just retrieve the authentication cookie and use it to create the claims principal in the hub that the browser is connected to. And this is basically what allows you to access your hub context in the hubs that you create and see that there's a user property there, which is the current logged in user, the current connected user. Now, Blazor makes no exceptions. It's just running over a particular hub called Component Hub. So how does the implementation of the authentication state provider, you remember the class that we just saw in the previous slide, look like in Blazor Server? Well, it's a pretty simple implementation. It's called the Server Authentication State Provider. And the only thing that we need is making sure that we can retrieve this. So the Component Hub needs to retrieve this its current claims principal and set it in the instance of the current scope of the Server Authentication State Provider, and that's it. So it's a very simple implementation. It just exposes a set authentication state method, and that's how basically Blazor Server is capable of retrieving the current the current principal of the application. So this means that if we look at which providers we can support in Blazor Server, well, we definitely support the things such as ASP.NET Core Identity or Azure Active Directory both the enterprise or B2C, just because they work with the ASP.NET Core. Again, Blazor Server is just leveraging an existing feature which already is there for ASP.NET Core and SignalR. So basically, anything that works with the ASP.NET Core will work with Blazor Server securely. So let's have a look at how this works. So let's jump to Visual Studio. And now the interesting bit is that I just came to know a couple of days ago that in the WebEx, if I do Control-Shift-B to compile my application, it will show a whiteboard and disconnect my sharing screen. So I'll try to avoid that, but I'll do my best, but don't blame me if it happens. Cool, so we have this as server individual application. This is basically just the normal template of that you can create from Visual Studio. If I do Control F5 and I launch it, well, Visual Studio compiles it, I go there, and if I try to access my counter page, I see this message saying that I'm sorry, but you may not see this page. And this is because, like we were seeing on the slide, in my counter page here, I have my authorized attribute, and in my app.razor, where I've defined my routing, I have something like this, right? So this is the message to show when the user is not authorized. However, if I just add a counter here, right, and I relaunch the application, I will see the counter. So this is the important bit I wanted you to be aware of. The authorized attribute only works when we are dealing with routing, okay? Cool. Now, let's log in here. And as you can see, the moment I hit the login button, what happens is that I've left the Blazor application, and now I'm in the normal ASP.NET Core identity page where I perform the login. And the moment I hit login, I just get redirected back to the page where the Blazor application sits, and now I can finally access the counter. I see that here. I also get a greeting message, and this is because if we go and have a look at the login display component, this is the component that goes on the top right corner of the main layout. As you can see, there's this authorized view that can differentiate between when I'm authenticated or not, and when I'm authenticated, it shows me a greeting message. Otherwise, I have a couple of links, and again, these are the ASP.NET Core, ASP.NET NDC, basically identity links to the login or register pages. Okay, if we go and have a look at the startup.cs file, what we get is other than obviously the registration of ASP.NET identity, I see this add scoped authentication state provider, which is the abstract class. That points to this bizarrely named class revalidating identity authentication state provider, or blah, blah, blah. But if I go and have a look at the hierarchy of inheritance, as you can see, this ultimately inherits from, hopefully I can get to the definition of this, inherits from the server authentication state provider that we mentioned on the slides, and this is the class that exposes to the set authentication state, thanks to which the component hub can set the current principal for this instance of the application, right? The reason why we're not using this directly, but we're using that this class here is simply because we want to support the remote sign-out capability that we have in ASP.NET Core by checking that the security stamp of the user is still valid. But apart from that, the principle by which it works is exactly the one that I've described to you on the slides. Okay, so I would say that this could be enough for Blazor Server. Again, the cool stuff is in Blazor Web Assembly. So let's go ahead with that because it's probably more interesting. Okay, so how all of this is different in Blazor Web Assembly. So in Blazor Web Assembly, as you know, we have our C# application running on the browser and interacting with the DOM. So per se, this application is obviously not capable of managing users, all right? I needed to rely on an external identity provider, which could be either the hosting application, Azure Active Directory, or for example, could be Identity Server 4, which is what we're going to use during this talk. And How does Blazor interact with Identity Server? Do we have some strange C# code? Not at all. We are using oidclient.js. It's a piece of JavaScript, which is referenced by the portal, and it's basically the probably the most commonly used JavaScript client for the OpenID Connect protocol, right? So it's not made by Microsoft. It's pretty much an industry standard, and so this is why how Blazor interacts with the identity provider. Under the hood, again, we need an implementation of the authentication state provider class, and this implementation is called the remote authentication service. And the way this works is very, 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 again, simple. It's just, so let's pretend that I've already authenticated the user via OIDC client in some way. We'll see how in a second. So there is a token being passed by IS4 to my browser and stored in the session storage by OIDC client. The only thing that the remote authentication service does is using JS interop to retrieve this user from JavaScript and create a claims principal within the application, right? So this is really it. It's as simple as that. And how do we trigger the authentication process, or perhaps the sign out? Well, it's done through another interface implemented by the same object, okay? So remote authentication service also implements iRemote authentication service, which exposes the two methods, sign in and sign out. And these methods will just trigger, again, they're just wrappers around the logic, which is within OIDC client, right? They will just trigger the function in JavaScript. However, we're pretty much never going to use these methods directly, because the default template comes with this page here called Authentication, which internally uses this object called Remote Authenticator View. And what is that? So this is an object that wraps the logic around all the flows that happen during an OpenID Connect interaction between the client and the identity provider. And without going into much detail, the concept is that it exposes this action property. We call it with the flow that we want to trigger. So for example, action equals to login, and this will trigger all the entire thing for me. Same for profile, or even the callbacks that we might receive from the identity provider. So there's a login callback action, for example. Cool. Which providers are supported in Blazor Web Assembly? Well, we have obviously Identity Server, Azure Active Directory, and Active Directory B2C. The first two are available directly from Visual Studio. For the third one, we need to still use the .NET CLI. But basically, anything that works with OIDC client, so implements OpenID Connect and OAuth, can make we can make it work with Blazor Web Assembly. Sometimes, from my experience, we need some tweaking, but it can potentially work. Cool. Let's have a look at all of this in Visual Studio. So let's go back here in the solution. Let me close these files, and as you can see, I have this Blazor Web Assembly folder in which the first project is Identity Server 4. And in Identity Server 4, the configuration for the security aspects, or which clients are authorized, is usually either in a configuration file or in a C# file like this one, right? So if I go and have a look at this C# file, what I have here is this client called Blazor that I have configured, in which I've specified a few things. So first of all, it's a single page application, so I'm using a grant type code. This is the type of workflow that we're going to implement with OpenID Connect. It supports the proof key code exchange security protocol. And the other important thing that I'm specifying here are the scopes that this Blazor application is allowed to request. And what are these scopes? A scope is basically think about it as a set of claims, a predefined set of claims that Blazor can request and then receive. So here I have OpenID and profile. These scopes are defined here in this section. I can potentially add another one, like I don't know. There are a few predefined here in IS4, for example, email. And I can say that, yeah, Blazor can request also this email scope, right? Plus a bunch of other parameters like the course configuration, redirect URIs, etc. Cool. If we go to Blazor Web Assembly, so I have this application here. Let's have a look at what I get out of it. If I click on the program, this is pretty much the default template that you obtain when you decided to go and add a new project to your solution. You select a Blazor application, and here in this page, you say that you want individual user accounts. So all that you get is a very generic configuration that starts with, that basically only has this add OIDC authentication extension method. And then you have to provide the configuration. You can provide it either by code or in a configuration file. In this example, it's by code simply because it's more clear for our scopes. But then we will see later how to configure it via app settings. So what do I have here? I have basically the counterpart of all the things that I've set in IS4. So I have that the client ID is called Blazor. The type of flow is going to be code. If I want to, the two scopes, OpenID and profile, are already predefined as default parameters, but I can add some additional scopes. So for example, the email one that we've added before, and that's pretty much really it. So let's start these two projects. So let's begin by starting the identity provider project. All right, so this is IS4 running, and now let's go to the Blazor application. Control F5, not Control Shift B, and let's run this. All right. So how does it work? Here I've also set my counter page behind the authorize attribute. So if I click counter, I get redirected, as you can see, to Identity Server 4. Just by a chance, how did I do that? Well, if I go to the pages and look at the counter, I have my authorize attribute. What happens to be here in the routing this time is a redirect to login component. This is a component which is here in the application, and it just navigates to the authentication/login endpoint. Okay, this is the page that uses this remote authenticator view thing that we've seen on the slides. And so this allows me to log in. I can log in as Bob, for example, and here I get my consent screen. I consent to these claims, and now I'm back to the application. I can successfully access my my page. If I log out, I can re-log in as Alice, the other user, default user that I have here, and everything will pretty much work exactly in the same way. Cool. So this is the very basic thing that we managed to do, and it's really not that useful unless we are capable of calling an API, right? So this is going to be our next task. So how do we call an API? What do we need to do? Well, what do we need to do is basically requesting an access token for that API, for this protected API. And in order to do that, we have this third interface implemented by the remote authentication service called iAccessTokenProvider. This provides a request access token method. When I call it, again, just a JavaScript interrupt. It calls an OIDC client, which will request an access token to the identity server. What's an access token? An access token is pretty much similar to the ID token we've seen before. The only difference being that it's not meant to be consumed by my application here. It's meant to be just considered opaque by this application and forwarded to the API we want, to the resource that we want to consume. This access token contains the identity of the user, which means that in the web API, I will be able to access the claims principle of the HTTP context, right? So it's basically like Blazor was impersonating the logged in user when making this call to the web API. All right. So we need to request the access token and embed it in the subsequent request by the as a bearer token in the authorization header. The good thing is that we don't have to do it manually. Okay, Blazor has some automatic components that does it for us, and it's called authorization message handler. It's basically a component that gets embedded in the HTTP client pipeline and can automatically retrieve this access token for us either in the local cache or by querying IS4 and add it as a bearer token in the authorization header when making the request to the weather API. And we will see that in action in a second. All right. Cool. Let's see how all this works. I need to close these two running applications, and let's go back to Visual Studio. And so what do we need to do? First of all, let's go back to my identity provider. And here, what I have is I've defined an API resource, right? So this is my web API that I want to be able to call. I gave it a name, and I've said that when someone asks for an access token for this API, these are the claims that need to be added to this API, right? So this is just another scope that we can request to Blazor, provided that these are it's among the allowed scopes that we have now here in IS4. Okay. But apart from that, it's just these are the only changes that we need to do in Identity Server. And then I have a weather API project, and in my weather API project in the startup, I've configured that I want to use the JotBearer authentication scheme. And here I'm saying that, yeah, this is the authority which is going to issue those tokens. I expect an audience on that token called the weather API. And then I've also specified the claim type that is going to represent my name. That's it for the configuration. It's just the default standard configuration for Auth 2 in Web API. The other thing that I've done is that here in the weather forecast controller, I put my authorized attribute so that only authenticated user will be able to call this controller. And to show that I get the identity of the user back from IS4 as part of that token, I'm also returning the name of the user as part of the response, right? So pretty standard stuff. Let's have a look at Blazor. And if you played with it, you know that you call, there's this default page called fetch data that will call this API. Since the API is protected, I felt that it was good to protect also this page with the authorized attribute. I'm injecting an HTTP client, and all I do to populate this page is making this call here, in which I'm just I'm just calling the get endpoint that I'm exposing here, right? So I'm not dealing with any type of authentication whatsoever in this particular page. Everything will be configured in the program.cs file. So what do we need to do here? Well, first of all, we need to say that we want to request also the weather API scope as part of the default scopes that their API as part of the default scopes. And then I need to configure the HTTP client that I'm going to use in my fetch data, right? I need to make sure that I can inject an HTTP client in this page. How do I do that? Well, I can register via HTTP client factory this weather API client, name it client whose base address is this one. And then the idea is that I'm going to register also as a singleton. This is pretty much the equivalent thing of saying, yeah, this thing here. So every time someone asks for an HTTP client, I just return the client from weather API. That's really it. And then the last bit is configuring this client in order to request automatically this access token when invoked. And we can do that by this add HTTP message handler method. And here we're configuring this authorization message handler. And what we're saying is basically that every time we hit an endpoint whose domain is localhost 5002, which is my API localhost, this message handler needs to make sure that there's a weather API access token embedded in the request, right? Cool. Let's hope that everything works and see it in action. So let me just switch to multiple startup projects, and I can finally do a Control F5 and launch this. Right. So IS4 has started, the API has started, and as you can see, it's returning me a 401 because I'm not authorized to access this endpoint just by a GET. I need to include, obviously, an access token to it. Let me close a few tabs here. And if I go to Blazor and I hit the login button, let's log in this time with as Alice. I hit login, and I get asked for the consent over my weather API scope as well. I hit yes, and let's have a look at what happens during the call. So if I go to fetch data, I effectively can get the data back. As you can see, the API was capable of recognizing Alice Smith. And if we look at the request here at the bottom, as you can see, there's this bearer token which has been automatically added to the header of that request. And the content of this bearer token is something we can easily explore with a website like jot.ms. And as you can see, is Alice Smith for an audience of weather API. So that's why the API is recognizing it, and it's issued by our identity server, and it has a scope of weather API within it, right? Cool. So we've already achieved a lot in 35 minutes, but we can do more. And so let's go back to these slides one sec, because obviously being able to call an API, it's interesting, especially a secure API, but any real-world application will need something more than that. And more specifically, we need to be able to differentiate between users. So we want to assign some user, we want to define roles, assign some users to some roles, and restrict some part of the application to only those people belonging to those roles, all right? So what are roles in a system like the one we have set up here? Well, they have a slightly different meaning depending on the standpoint we are looking at them from. So for example, from the point of view of the identity provider, identity server, a role is just like any other claim, okay? So it's just a claim that we need to configure to be added to either the ID token or the access token so that it can be consumed by the client application, all right? From the point of view of the application, it's a very special type of claim because we have some specific logic attached around it, right? And in the specifics here, what happens is that we want to make sure that these roles are recognized by the framework so that I can say authorize role admin, and there's a lot of work that is done automatically for me to check for that claim to be present in the claims principle and allow or prevent access to a given resource. And this is going to be pretty much the same both for the client application, for the Blazor application or the Web API application, right? Cool. So let's have a look at how we can implement this. And in order to do that, I need to do a couple of things. So first of all, I need to close these running applications here. Let's go back to Visual Studio, and I need to switch to a different branch. So let me go to changes here. Let's comment this and go to branches, and let's go to roles here. All right, so again, let's have a look at what we need to do in the three components of our solution here, and start with with identity server. Well, if we look at the startup in identity server, we are basically using ASP.NET Identity under the hood, and ASP.NET Identity already contains a logic to fetch some roles from the database if these roles are present. And it turns out that in the demo database that I have here, let me just retrieve this open the database here, and if we run this query, as you can see, I've already added Alice to the user role and Bob to the admin and user role, right? So ASP.NET Core Identity will already fetch these roles for me. But all I need to do then at this point is configuring IS4 in order to return them as part of the two types of tokens that we can release, the ID token and the access token. How do we do that? Well, we need to configure them as a resource here in this particular property here. And we have a couple of options. Either we can define a specific bespoke identity resource for the roles. An identity resource is basically just a name for the scope and a set of claims that we want to add to it. Or, probably better, let's just modify this identity resources profile, this predefined set of claims that we associated to the profile, to include also this role claim, so that we don't have to request a specific scope in order to get the roles from the client. So what I've done is just creating this class called profile with the role identity resource. This class is basically just inheriting from the default identity resources profile, and I'm adding the role scope to it, right? A very similar thing is what I've done here in this API resource. I've just added that I want the role claim to be added to it as well. And then for the client configuration, it's absolutely the same thing. I don't have to touch anything else. Let's go to the weather API. And here in the weather API, again, no changes in the configuration whatsoever, nothing to do here. The only thing I've done is that in my weather controller, I'm now restricting the capability of calling this endpoint only to Bob, basically, only to those users who belong to the admin role, right? What do we need to do in Blazor instead? Well, let's have a look. So first of all, well, in the counter page, I've set that a user can access the counter page, and same goes for the fetch data page. Here I'm saying that only admins can add it. There's no point, there's no reason for a normal user to access this page because they won't be able to call the API. What about the configuration? Well, all I need to do is specifying that I want to use the claim type role as the role claim, and that's really it. I don't have to do really anything else. So let's see if all of this works. So let's do Control F5 and launch the application. So I'm now not authenticated. I log in as Alice. Alice, if you remember, is a user, just a user, it's not an admin. If I say yes, I can go to the counter page. Now perfectly works. If I go to fetch data, I see, sorry, you're not authorized. Oh, and by the way, this is interesting. I slightly changed the routing as well, because obviously, if I'm not authorized and I just blindly redirect the user to the login, I would have been stuck in an endless redirect loop here, right? So I check if the user is authenticated. Only if it's not authenticated, I redirect him to the login. Otherwise, I just display this message saying that you're not authorized to access the resource. Cool. Okay, fine. Seems to be working. Let me log out and log in as Bob and see what happens with Bob. So I have this user here. Hit login. Yes. Go to fetch data. Damn, you're not authorized. And I'm not even authorized to access the counter page. What the heck is going on here? So let's look at the claims. This is a claims page that I've set up. And as you can see, it seems to be, everything seems to be okay. So I have my two roles, user and admin, as Bob Smith here. And they are coming from, as I said, from the object that sits here in OIDC client. So this is the counterpart of the claims principal that sits in this client. And as you can see, I have my array of roles here, right? User and admin. So everything seems to be working correctly. Why is Blazor not recognizing it? Well, it turns out that unfortunately, there's a bizarre behavior that Blazor has when a claim is an array. Like what we have here. It is basically just grabbing the string representation of the array, and it's creating a corresponding claim, role claim in the claims principal object with that string representation. And this obviously doesn't work with the authorized attributes that I put here and there, right? So we need to, basically, in order for this to work, we need to modify the component of Blazor that transforms the user that exists in an OIDC client into the claims principal. And the way we do it is by adding a custom account claims principal factory. So this is the object that performs that transformation between the JavaScript word and .NET word. And I have created an implementation of it called the array claims principal factory of a remote user account. And if we go and have a look at this class here, it's relatively simple. So it just inherits from the default account claims principal factory, all right? And overrides this create user async by calling the base implementation, right? So what I get out of this call is basically a claims principal. Hope you can see it. But then what I do is that I iterate over this dictionary of all the properties of the object in JavaScript. And for each of them, I check whether the object is either, let's remove this. It's a JSON element and it's an array. And in case it is, like for example, for the role claim, I remove this role claim and I add two separate claims, one per each value, right? So in a nutshell, it's perhaps easier to watch it in action than just explaining it. If I launch this again, and I log in again as Bob Smith, what happens is that now my claims are like this, right? And this is what allows the authorized attribute to work correctly, and also the call to the weather API service, okay? So it all works pretty much seamlessly. We needed to just tweak a little bit the way this JSON object gets deserialized into a claims principal. But otherwise, it's pretty simple. Cool. Let's go back to the slides, because there's one thing I really don't like about roles. So I tend to avoid using roles as as the way I model the authorization for my application, because there are some drawbacks if you do that. Well, first of all, as you know, if you've done it already, well, it's very easy to get your roles end up scattered across the entire code base. So if you have an API, for example, with 100 different endpoints, you're most likely going to have 100 authorized attributes with role equals to admin or role equals to user. And if I ask you, okay, can you give me the list of the endpoints that a user can call or an admin can call? The only way you can do it is going through your entire code base. There's no holistic view of what a user can do depending on his role. And this is annoying. The consequence of this is that factoring in permissions is incredibly hard. The moment I ask you to add a super user, role which sits kind of in the middle between a user and an admin, good luck with that. You probably will need to change dozens of files, right? Simply because, again, you have these roles scattered everywhere. And this always leads to inconsistencies, like, I don't know, for example, endpoints that can be called by users, but not by admins. That's bizarre. But I bet that it has happened to any of you pretty much once. So, yeah, it's just annoying. The other thing is that usually, you want also the front end to react to the roles that a user belongs to in order to perhaps hide or display some parts of the application, enable or disable some buttons. And it's not easy to do that. I mean, the only thing that you can do is duplicating the logic on the front end side, pretty much like we did in the simple example 2 minutes ago, right? So the fetch data endpoint can only be called by admins. So there's an authorized admin put on the backend side, and I need to put another authorized admin on the front-end side. There's no other way to do that, right? So can we do better than this? I think we can, because well, it would be difficult to do any worse than that. And I've just released a package in NuGet that simplifies this task, right? It's called the des.asp.NET Core Permissions. It's still in a very rough state because I literally rushed it to the NuGet gallery before this talk. But you can also download the source code in my GitHub account. And yeah, I've used it in production in a number of different real-world applications. So it kind of, it works. And it's inspired by Policy Server, which is a commercial product made by the same company responsible of Identity Server. There's in this GitHub link, there's a kind of a proof of concept of a local version of Policy Server. I think that my implementation is even lighter, but yeah, it does its job. How does it work? Well, first of all, we start from a centralized place where we can describe our functional permissions. And this could be either my app settings file or a separate file, right, in which I have my permissions, sections, and I define things such as, for example, can let passengers board an airplane, and you can only do it if you are either the captain, the first officer, or a cabin crew member. Or, oh, sorry, there's a spelling mistake here. You can fly an airplane. Obviously, you need to be either a captain or first officer as a role. And you can also add additional claims to this permission here. For example, blood alcohol level equals to 0. Or in the case of our examples, I can just say, can see forecast role equals to admin, all right? Something like that. Now, the library will automatically create policies out of this configuration so that I can just say that the get endpoint for weather forecast is going to be authorized only to people who can see a forecast. And the same goes to the front end side, so that either in Blazor and or in the API, I just refer to the abstract permission that I have here. And the moment I need to refactor that permission, I do it in a centralized place, all right? I don't have to modify different files or different locations of my source code, both in the front end and in the back end, for example. The other good thing is that the module also exposes a /mypermissions endpoint. You call it with an access token, and it will return the permissions that that user is entitled to. And you can use those permissions to hide or show pieces of the user interface. Right, so let's see this in action. Cool. So let's go back to the solution here, and as usual, I need to close all the running instances here and move to a different branch. So Theme Explorer changes, and let me reject those changes here. Discard. Reject those changes, and let's go to this permissions branch. Okay, so what do we have here? Let's start with, as usual, with Identity Server. And if I go to my config page, here I don't have any changes whatsoever compared to what we had before. And this is because roles are an application kind of concept. So IS4 just will return me, permissions are an application kind of concept. IS4 will just return me my roles, and that's it, right? And I will be responsible of mapping them to my abstract permissions, my functional permissions. So no changes whatsoever on IS4. If I go to my weather API, what I've done here is that in my, well, first of all, I've added this permissions.json file, right, where I have can see forecast, can use counter, right, mapped to the relevant roles. And I've added it as a separate file. I could have embedded it to the app settings.json. The way I did it is just adding this additional configuration file, right? Again, you can just use one single file. I just prefer to have it separately. And then in my startup class, what I've done is just calling this method, add permission policies, which comes from that unit package. And since we also have a middleware, I've also added this my permissions middleware. That's really it. And thanks to that, I can now go in my forecast controller and say that this action is perhaps only allowed to those who can see a forecast, right? And if we look at the overload that I'm using, yeah, this is using the policy overload, right? So the module will automatically create the relevant policies for me based on that file. Cool. Let's go and have a look at Blazor, what happens in Blazor. So first of all, if I go to my counter page, I have authorize can use counter, and same goes to my fetch data page, right? Authorize can see forecast, right? So I'm reusing the same permissions that I have in the backend also in the front end. And the nice thing that I can do thanks to that is that I can now go to, for example, my menu page, my menu component. So the thing that displays all my links on the left-hand side of the page. And here, as you can see, I've added a couple of authorized views here and here that will just add the links to those menus only if the person has the right permission, right? So again, I hope you appreciated that there's no duplication of authorization logic here. I just define what those permissions as a combination of claims. These are issued and managed by the backend API, and I just use these names, these permission names, as the authorization policies for various parts of my UI. Right. What do I need to do also in Blazor for this entire thing to work? Well, I need to first of all add a custom authorization policy provider. This is basically what Blazor uses when it sees something like this policy. Can use counter. Okay, how is can use counter defined? And this is basically done by this implementation here, permission policy provider. And if we look at this implementation, what I have here is that I just look for a specific claim, a special claim called permission in my claims principle. Okay, I'm just returning. So give me the policy name, can use counter. I just return an authorization policy builder, which is satisfied only when I have a permission called can use counter in my claims principle, right? And how does this permission claim end up in the claims principle? Well, this is done by, do you remember the custom array claims principle factory that we had created before? So if we go and have a look at this now, I have this additional logic here, right? This piece of code here in which I'm calling the weather API, and more specifically, I'm calling the my permissions endpoint of the weather API. And then I'm just, this will return me an array of strings, which are all the permissions I have as a user. And I will just add a permission claim for each one of them to the claims principle. Okay, simple as that. So let's see it in action. So I do Control F5, launch the application. And let me close some of these tabs. As you can see, I don't have the link to call the counter page or the fetch data page, simply because I'm not authorized to them. I can obviously go there by typing the URL, and in that case, there's the routing that prevents me to seeing this page. But again, it's a better user experience that I'm not seeing these links if I'm not authorized to see them. Okay, then I can log in as let's log in as Alice first. Right, so I need to do this here. Let's log in as Alice. Okay, and the moment I log in as Alice, see the counter page, link to the counter page. I don't see the link to the fetch data page, because if I go and have a look at my permissions, this is the permission I've retrieved from the backend. Only can use counter, right? And this is also added as a this is obviously added as a claim to my principal. Obviously, again, I can go manually to fetch data, and in that case, I will see, sorry, you're not authorized, right? So I'm still protected. It's just a better user experience for the user. I log out, and I now log in again as Bob, who's an admin. I now see both links because I have both permissions, and I can go to fetch data and see my weather forecasts, okay, because I'm entitled to see them, right? Cool. Guys, I think the time is pretty much over, and so this is all I had to show you for these subjects. Yeah, there is some additional info on my blog, so you can go there, and I've written a couple of articles. There are more coming soon, so follow me on Twitter if you want to be notified when I release these new articles. Yeah, just a big thank you for having spent this hour together with me. And yeah, this is the GitHub link where you can download the demos. I will post it on Slack as well for your benefit. So yeah, if you have any questions, feel free to open your mic and ask.